All right, what we want to do is to find the inverse of a square matrix. So in this case, we're going to start with a 2 by 2. To do so, what we do is take 1 divided by a times d minus b times c. Well, if you're familiar with that procedure, what that is just the determinant of the matrix itself. So this is just 1 over the determinant. Next, what we want to do is to change the position here, or swap A and D, and take B and C and take their opposite. So you can see that right here. Let's show you how that works down below. When I have the matrix A, B, C, D, I'm going to raise that to the -1. And what that will do is find the inverse. Yep. If I scroll up here just a little bit, you can see what's happening is that I've swapped A and D, and I've taken the opposite signs of B and C, and their denominators here are the determinant of that matrix. Let's take a look at this with a real example. In this case, I have 1 times 5 minus 3 times 2, which is a -1, and that's the determinant. 1 divided by -1 is -1. Now what I want to do is swap the 1 and the 5 and change the signs on the 2 and the 3. Let's see how that works. Yep, we got what we expected. Now you may look at the 2 and 3 and say, well, nothing happened, but remember that we changed the signs of the 2 and 3, and we multiplied by 1 over the determinant, which was also -1. Let's take a look at another example. See what you can do with this one. First, by finding the determinant, then taking 1 divided by the determinant, swapping the 2 and the 8, and changing the signs of the 3 and 5. Okay, very good. This is what we got here for the 2 by 2. Now the 3 by 3 takes a little bit of work. So let's show you what that one looks like. Here's a matrix, a nice 3 by 3 matrix. And what we want to do is just take the inverse of that by raising it to the -1. Okay, and there it is. You'll notice that it doesn't look anything like changing the signs or swapping stuff around. That's because we have 9 elements that are in there. Now there are procedures where you can go ahead and use determinants to find the inverse matrix, but I don't find them very efficient. So what we're going to do is use a method of row operations, which we're already familiar with. So here's that matrix. You can see it here on the left. Next to it is another matrix, which is in reduced row echelon form, the 1, 0, 0, 0, 1, 0, and 0, 0, 1. Our object is to get this reduced row echelon form over here on the left, and then on the right, what we'll be left with is the inverse matrix. We're going to do this with row operations, and I'm doing this on the Inspire calculator. So I go to my menu and I can find row addition. And what this will do in the first place is just add row 1 with row 3. That's the command that it gets here. So if I do that, you can see that that's going to give me 1, 0, 0 in that first column, which is what I want. The next thing I want to do is take a look here, and I see I have a 1, so I want to get a 0 down below. To get that 0 down below the 1, I'm going to take -2 times row 2 and add it to row 3, and then replace row 3. There we go. I've got my 1, 0, 0 going down that column. I got my 1, 0 in that column. So what remains here to put it in row echelon form is to change this -1 to a 1. So what I'm going to do with that one is just multiply that row by -1 and then replace row 3, and there that is. Well, I'm about halfway done here using just row operations. I have my 1, 0, 0, my 1, 0, and my 1. What I want to do now is get a 0 here, get a 0 here, and a 0 here. Now I like an ordered pattern, so I'm going to work my way up just like that. So I'm going to put my 0 here, then go for this 0, and then go for this 0 in that order. To get that first one, what I'm going to do is just multiply row 3 by 1, add it to row 2, and replace row 2. And here's the command for that. As I do that, I get my 0 right there, and now I'm going to go after this one. To clear this one out and make it 0, I'm going to add row 3 and row 1. So here it is. I'm multiplying row 3 by 1 and adding it to row 1, and that should give me the 0 up here on the top, what I needed. Now, I'm almost done. I've got my 1, 0, 0, I got my 0, 1, I got my 1 here, a 0 here, a 0 here. All I have left to do is to get a 0 here, and I'm going to do that using row 2. So, if I multiply row 2 by -2 and add it to row 1, I should have it. And there it is. You can see on the left, I'm in reduced row echelon form, and on the right, this would represent my inverse matrix. Let's compare that to the actual inverse. So I took the original matrix, and I'm going to raise that to the -1, and that should be my inverse. Now, if I compare that to what we just did here, you can see that the numbers are very similar. So I'm fairly confident now that we have that inverse matrix. And there's the procedure for finding the inverse of a 3 by 3 matrix.